Okay, so this is going to be our second and last video for day 9 of Unit 3 in Geometry. In it, we are going to talk about special segment theorems and circles. So starting with this one right here in front of us, so the secant theorem, all it's basically saying, and I'm not going to go through and work examples or anything because these are simple formulas to follow. But all the secant theorem is saying is one secant, right? So if two secants share an origin outside the circle, let's start there. One secant segment times its constituent, right? So the full secant segment multiplied by its exterior constituent is going to be equal to the same on the other, right? So we would say, let me put my little bars here so we understand that they're segments. Oops, I don't know why I put a P. Okay, so we're saying the secant segment AC multiplied by its exterior component is going to be equal to the same product of the other one originating from the same point A out here times its exterior component. Okay, so real easy. Okay, so next one is our tangent theorem, and this one's really simple. So kind of the same idea as the previous. We're originating from the same exterior point. So if we have two tangent segments originating from the same exterior point outside the circle, right, then it must be true that the two tangents are going to be equal in length. Okay, so the distance, and you can tell just from looking by this picture, and I challenge you to do it yourself if you have some kind of a compass. But you can tell just by looking at this picture that the two tangent segments are going to be precisely equal. And they have to be. There's no other way around it. Okay, so this one's particularly interesting. So this is the secant tangent theorem, and it says that the tangent segment, so AB here, and again, we see that they originate from the same exterior point A. But anyway, the tangent segment squared is going to be equal to the secant times its exterior component. Okay, so the secant AD multiplied by its exterior component. Okay, and that will always be true. Okay, and then we get, so now you see why in the previous video I kept drawing a radius before I would try to draw the tangent segment. Okay, and the reason for that, well, there's a few things that go to this. Okay, but the coolest thing about this theorem, is so AB is tangent, obviously, right? And BC is a radius. Okay, so they will always be perpendicular. Okay, so basically what this theorem is saying is that if you have a tangent segment cutting through a radius, we'll say through terminal end of radius, right? And of course, we just mean point on the circle, right? They'll always be perpendicular. So that radius and the tangent segment will always be perpendicular. Okay, so there's other things that go to this, but we're not going to get all into that. I'll keep this one simple. Okay, and then we have one that we've already seen previously, just as a little project, Thales' theorem. Okay, so Thales' theorem simply says if I have a diameter, AC, right, then the triangle formed by any point on the circle. So we have a diameter AC, and if we just connect it with a third point like this, right, it will always form a right triangle. Okay, and we've already gone over this. Okay, so the other thing that we can say is if I have, let's say I connected into two more, right? So right here, theta 1 and theta 2, right? Well, we can do any kind of trig that we need to do, right? But another cool thing, and you can't tell by looking at this circle, but another cool thing is that this triangle here, this obtuse triangle formed, BCD we'll call it, is always isosceles. Okay, so that means this angle and this angle will be the same. And that should make perfect sense because what kind of special segments are BC and BD? They must be radii. So BC must be equal to BD, which of course implies that triangle BCD has to be isosceles. Okay, and there's a whole bunch of other cool stuff formed from this. Like we can also say that theta 2 here is the inscribed angle of arc AD. So AD, arc AD's measure, right? So when I put that little degree symbol, I mean its arc measure is going to be equal to twice theta 2. Or conversely, we could also say that theta 1 is the inscribed angle of this arc here. So arc DC's measure is going to be equal to twice theta 2. Okay, so one last theorem. I almost cut off the video and completely forgot about this one. One last theorem, and this is just the chord intersection theorems. There's multiple to this, there's two. The chord intersection theorem tells us that, switch colors here. So first thing it tells us, and this is my favorite part about it, is that if you take these two arc measures rather, right? That's why there's the little degree symbols. If you take these two arcs, lambda 1 and lambda 2, divide them by 2, right? That midpoint between them, because that's literally what I did is calculate the midpoint between the two arcs, is going to be precisely equal to that angle right there. So that angle theta right in here is going to be equal to lambda 1 and lambda 2 added together. Okay, and of course, if we remember anything about lines and transversals, that would obviously also be equal to this angle here. Okay, the other theorem tells us that if we multiply, so we have two segments, two chords here, AB and DC, and they're intersecting at a common point of intersection E. Okay, so the second part of this theorem, the second thing that comes of this, is that if you multiply the constituents, so if I multiply AE times EB, it will be precisely equal to DE times EC. Okay, so we get two theorems from the chord intersection. Okay, so that does it for this video. These are the special segment theorems that I expect us to know. I'm going to obviously give you a handout that has these formulas on there. I'm not going to expect you to memorize them because it's hard even for me to memorize them. I'll be honest, I have a little paper open up here, kind of refreshing my memory. Okay, so we're getting to the point to where there is a crap ton of formulas, and it is borderline, I'm not going to say impossible, but it's tough to memorize them all. So I don't expect you to do so. But like I always tell you, make sure that you're keeping up with your formula charts. Okay, so that's it for this video. Give me a shout out if you need me. Goodbye.